Hi, everyone. My name is Chris Selleck. I'm a staff engineer here in the Durham office, and I've been at WillowTree for about 4.5 years now. Today, we're going to talk about how I trained a deep neural network to predict the outcome of NFL games. As such, and also because you have been warned I'm a dad, I've entitled this talk NFL Network. Like I said, thank you. You have been warned. So if you're anything like me prior to my NFL Network journey, machine learning is basically just literal magic. I have been fascinated by and dying to learn how to machine learn for maybe close to a decade now. I don't think I will ever forget hearing about AlphaGo back in 2016. Back then, it smashed records and all expectations by beating Lee Sedol, one of the best Go players in the world at the time. And quick fun fact about Lee Sedol, and this is one of my favorite tidbits I've learned in the entirety of my machine learning research. So Google's computer defeated Lee Sedol, making him the first human to ever lose to a computer at Go, and eventually, yes, really causing him to retire. Well, after Lee loses to AlphaGo, several new, far superior iterations of AlphaGo came out, and they needed to come up with a way to refer to the specific version that beat Lee. So as a nice little middle finger to poor Lee, they named it after him, AlphaGo Lee. Not cool, hilarious, but not cool. So I've wanted to learn machine learning for a long time. And finally, during a weird in-between projects phase a couple of years ago, I started looking into it. I found a great intro to machine learning kind of like mini course on Kaggle about predicting whether or not a given passenger would survive the Titanic wreck. After messing around with the data a bit, my algorithm got to be about 75% accurate at its predictions. And I thought that this was super cool. And also I'm a practical individual. So naturally, I immediately started trying to figure out how to use this to make mad money. As the slide points out, I first tried to predict the winning bet for NFL games. I was fairly disappointed to find out that step 3 there ended up being that the algorithm couldn't ever break 50% accuracy because the people in Vegas are very good at what they do, apparently. So it was back to the proverbial drawing board. I decided to make things as simple as possible and just try to get my algorithm to predict the winner of any given game. And for those of you who don't understand like over unders or how betting works, very much the boat I was in before I started looking into it. This is actually not the same thing as predicting a winning bet per se, but that's a topic for a separate discussion. So all my thing was going to do was try to predict who was going to win any given game. So now we're going to discuss the whole process and then the evolution of my algorithm. So first things first, meet Biff. This is actually an image that I had Midjourney generate with just the phrase artificial intelligence. And at this point, I'm about 90% certain that Midjourney is already self-aware and working on taking over the planet. But you know, honestly, we've earned this. Anyway, yes, I named my NFL prediction algorithm Biff. And yes, that is a Back to the Future 2 reference because I am who I am. The first thing I had to do was, the first thing I had to do to come up with my current iteration of Biff was to collect data. This is going to be your first step in pretty much any deep learning exercise because without data, you don't have anything to use for your predictions, or more importantly, anything to predict at all. The data collection process was very painful. I couldn't find any public-facing APIs containing the stats that I wanted for as far back into the past as I wanted. But what I did find was Pro Football Reference, which is a site that looks like it came out of the 90s, probably because it came out of the 90s, that has every single NFL statistic that you could ever hope for since the 40s, which is quite fascinating when you consider that there wasn't even an official football league until the 60s. Back in the 40s, it was just random dudes gathering together in a random field, beating the shit out of each other with a ball thrown in the mix and being like, no, we're playing football with our hands. Yeah. So to gather all of this data, I did what any sane developer would do, and I automated it. I automated it in the least way fun possible. To automate it, and again, all I have to work with are HTML pages. So to automate it, I wrote a script that would cycle through all of the teams for each year since 1979, which was the year I decided to start with. It was going to pull down the HTML pages from each team/year, query the HTML string using CSS selectors to find all of the relevant stats, and then write all of those stats to a CSV file. Through this process, I figured out a lot of super fun quirks about the NFL and its history. For instance, did you know that there was a player strike in 1982 that cut the season short? And that if you, I don't know, let's say wrote a script to query for a full season in that one particular year, that it would die midway through gathering all of the data since 1979 because it tried accessing game 10 of the 1982 season, which never actually happened, because I sure do. Another fun one. There have been 2 times in NFL history where 2 teams have played each other twice in the same year, with each team's home and away status being identical and the score being identical. So if at any point you're trying to use all that data together for, I don't know, let's say a unique identifier, don't. I ran into many just as painful situations as these while collating all of the data, but then finally I was done. And now, finally, it was time to start cleaning the data. This is another important step that you have to take when getting ready to train an AI on a data set, because not all data is created equal. Some data points just don't have anything to do with determining the outcome that you're trying to predict. In our example, the name of a stadium a game is played in, it probably falls into that category. Maybe the team's jersey colors. You don't want to feed data points like this into a neural network, or else at best, training is going to take that much longer, since it has to learn that these data points are useless. And then at worst, we actually get what's on this slide. It might actually find some entirely inconsequential link between stadium name and the winner of a game in the data set that you're using as the training data. Of course, that's not going to correlate when you're making actual real predictions on current games. Another reason for clearing your data is to get rid of inconsistent records. Despite the fact that Pro Football Reference has data on games played all the way back in the 1940s, some data points just aren't consistently gathered over the course of 80 years of NFL football. Weather was actually one of these, which was A, surprising, and B, pretty disappointing to me, because I thought that one was going to be a pretty important data point. But if you only have weather data for, let's say, 40% of the games that you're training on, it's probably going to hurt rather than help training time, because now it has 60% of the data where it has to figure out what to do when it has no weather data. So now I've gathered and I've cleaned my data. Is it time for training yet? No, almost, but no. The next step was determining how I was going to feed the data to the algorithm, and then the type of the algorithm that I was going to use. To save you time, and in all honesty, mainly me, the embarrassment of attempting to discuss the finer points of machine learning that I actually don't know very much about, I'll give you a broad description of what I went with. At first, I thought I could feed, she's supposed to be feeding the computer data. Special shout out to Midjourney for representing data as scrambled eggs. So maybe this is a look into AI psychology or something, the scrambled eggs, but I don't know, not important. But yeah, I first thought I could feed Biff each team's season stats going into a game to make its predictions, like all the season stats up to this game. But then I realized that those stats would all be zeros for every week 1 game, which would make it impossible to make any predictions off of. So I added the previous season stats as well. And then this is what Biff was going to get to make a prediction. And that's what Biff iteration 1 ended up being. I trained it. That's right. We're on the training now to predict the outcomes of NFL games by giving it each team's current and previous season stats, and then it would spit out its prediction. So are we done? No. The results were not super encouraging. It was only like 58% accurate. And like maybe that high. I don't remember the exact number. It just wasn't great. But it was at this point that one of our very own superheroes here at Willow Tree stepped up to offer his assistance. That's right, Michael Freenor. For those who don't know, Freenor is Willow Tree Classic's like data science guy. Also, at least in his Slack profile picture, he looks exactly like Jake Gyllenhaal. So he recommended a new type of neural network for me. This network is, very confusingly, in my opinion, named a long short-term memory network. Like, is it long-term or is it short-term? Is it both? Who named this? The point is, and this is insane and super creepy, that this type of network has memory. You feed it data in a series of time steps, and it learns how to use earlier time sets in your data for predicting future time steps. So I picked a completely arbitrary number, 20, and then reworked my data until I was now feeding Biff each team's 20-game history going into a given game. And it actually had a very nice effect. It had gotten up to 63.3% accuracy. And before we compare this to any other accuracy numbers anywhere, let's talk about what the 63.3% is actually measuring. Before you start training your network, there is one important step that I actually didn't mention yet. You need to split your data into training data and test data. Why? Are you ready to be creeped out again? Neural networks, long short-term networks or otherwise, will remember data that they've seen before. If you train a network on a data set and then test it against that same data set, your accuracy is going to be highly inflated compared to its real accuracy level at making real predictions. This would be like you getting your hands on a college classes final the week before the test and memorizing the answers. This isn't actually testing your knowledge of the subject, just your ability to straight memorize things. Something similar actually happened to me at one point during the training process. I had this one training run going for several hours and the accuracy just kept going up until it was hitting like 80-some% accuracy and I knew something was wrong. When I dug into it, I realized that I was feeding Biff the data wrong, and it was learning to predict games that it had seen the results of in previous time steps. So you remember how I said that like a long short-term memory network gets fed the data in time steps? Because of the way I was feeding it the data, Biff had learned that when asked to predict the outcome of week 4 of year 2015 for, let's say, because I'm a glutton for punishment, the Panthers. They probably lost, spoiler alert. Week 4, year 2015. It already knew the winner because it had previously seen week 4 of the Panthers' 2015 season when it was training on week 5 of the Panthers' 2015 season, because week 4 would have been the previous week. It was realizing that it was getting the previous time step in previous test cases and learning from that and looking at the scores at that game to figure out who was the winner in that game, which is absolutely mind-blowing to me. So in order to properly test your algorithm, you need to split your data up. A majority of your data should be used as your training data, and then the rest of the data is data that your network will never see again until, will never see until you're ready to test its ability to make actual predictions. For Biff, that looks like this. Games from 1979 to 2009 were the training data, and then games from 2010 to 2019 were used as test data. And I started doing this in 2020, which is why it stops in 2019. I was going to train Biff on the data set on the left, and then I was going to check its accuracy by giving it brand new games it had never seen on the right. And that data set, the one on the right, 2010 to 2019, is where my 63% accuracy came from. It was 63.3% accurate in predicting the winner of all games between 2010 and 2019. And I'll be honest, When I first saw 63.3%, I was a little bit disappointed. That seemed very low to me. But then I realized, what exactly am I comparing this number to, right? 100%? In that case, yeah, probably not good. 30%? In that case, that'd be great, right? The point is, these were all just arbitrary numbers. I needed, that's right, more data. I figured a great way to gauge Biff's performance would be to rank it against the best of the best humans who do this for a living. So let's take a quick look at the last few years' leading experts to see how good 63.3% accuracy actually is. As it turns out, even the best humans who get paid to do stuff like predict NFL games have a hard time even getting to 68% accuracy. This year is 2021's top 4 analysts, excuse me, on NFL Pick Watch. So we got 68% accuracy up there. That's probably the highest, 67, 66.9. Here's 2020's top 4 analysts. This was, I guess, a year with far less surprising results because we got 69% accuracy, 68.5, 68.9, 68.2. And then finally, here's 2019's. These top out at 65.8 accuracy. So 63.3% is looking a lot better at this point. And those of you paying close attention might have noticed that none of the names repeated from one slide to the next just now. It seems that it's a lot easier to hit 69% accuracy for one season than it is to maintain that level of accuracy. So what do top analysts' long-term accuracy scores look like? I took a look at the lifetime record for the top 4 2021 analysts on NFL Pick Watch. And lifetime records in this case just means the entirety of their data on NFL Pick Watch to date. And then I have like the total years next to their names there. And so if we take a look at these, the highest is 66.9%, and then the lowest is down at 64.7%. So 63.3% is suddenly looking even more than better because Biff's long-term performance is closely competing with the top human analysts alive. And that's not even the craziest part about this. Are y'all ready for the, wait for it, kicker? I warned you. I told you, I'm a dad, I'm sorry. The kicker here is that Biff has absolutely no knowledge about player data. So injuries, retirements from one season to the other, trades, it doesn't know anything about any of these things. And to emphasize how big a deal that is to those who might not know much about NFL football, if I told you right now that Davis Mills was injured and missing a game this week, even some NFL fans might be like, okay, that's probably not good for his team, but who is that? If instead I told you that Tom Brady was injured and missing a game this week, even those of you who probably know nothing about NFL football are going to know, if only because you recognize the name, that's really bad news for his team. Biff doesn't even have that name recognition. It has zero knowledge about players and injuries, and it's still competing with the top human analysts alive, even when they do know about player injuries that are going to affect the team's performance when making their predictions. And that leads me perfectly to the last part of my talk, which is Biff 3.0. But before we talk about that, real quick, I plugged in football player injury into Midjourney, and it gave me a football player whose leg has fallen off. I mentioned that I was pretty sure Midjourney was sentient earlier. Is this a threat? I, for one, welcome our new computer overlords. So Biff 3.0, obviously my hopes are that it's going to outperform V2. My ultimate goal is to get it to perform at the level of top human experts or better. And to do that, my next step is going to be feeding it that player data it currently knows nothing about. That is currently in process. It's something I've been working on when I have the time. And unfortunately, in order to hear about it, you are going to have to come to my Biff 3.0 talk once I finish that work. In the meantime, if you want to keep up with Biff and what Biff is doing, you can follow me on LinkedIn. I am Chris Selleck, or Twitter. I am Selleck. I post Biff's predictions every week during football season around Tuesday or Wednesday so that I and everyone else can track what he's doing live each week. So with that, I'll open it up for questions. If you're here in the Durham office, you can just kind of like yell. And then I have a questions thread if we need it in the Charlottesville Grow office. If you can't like vocalize a question, you should be able to speak up and we should be able to hear you. Fire away. Mickey. Yeah. 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 So that's a good question. He asked if I'm seeing any insight into what's going on inside the black box, essentially. Like, do I see which data points correlate most highly to correctly making a prediction? I don't see that when I'm working on my own. Google has this, I can't remember what it's called, Vertex AI or something, some kind of cloud service where you can feed it some data and it'll automatically figure out which data points are the best and like give you a graph. So I do have like a picture of a graph that I got off of Google with that, which is super cool. Points 4 was number 1. The number of wins was like number 3 or 4, which I found surprising. And then some of the things weren't surprising at all, like ties obviously had no relation to anything. But yeah, so on my own, it would be a black box. If I didn't have Google, I don't know how I'd get those numbers. I think I have
Chris,
Zoom
we have some questions. I'll put them in the chat if you'd like.
Yeah, cool. Sagar Patel is asking, sorry if I murdered your name. Have you compared LSTM with other algorithms? The only other one that I've compared it with was the one that I originally compared it with, which was no time steps, just you're going into the game. Here's team A's stats for this season and the previous season. Here's team B's stats for this season and the previous season. Okay. Someone else asked if you feed Biff player stats from the last 10 to 20 years plus team win-loss stats, would it be more accurate or almost the same as just the team stats? I don't know. That's what I'm working on right now. I'm hoping it will get better. Okay. I'm trying to figure out the answer first. Okay. Sean asked if I'm giving it just player data or player data like in context with the teams that are playing. The hope is the latter. I had to get creative about how to do this because I couldn't, how do you tell a computer that Tom Brady's Tom Brady? And so what I'm doing is creating a separate LSTM network that is going to try to predict like essentially their fantasy score for a given week. And then it'll spit that out. It'll spit a prediction out for that, especially given it's like their injury status going into a game. And then I'm going to use that and feed that into the original Biff calculation. So it's going to have like team stats plus its player stats, or at least it's like starters stats on offense. I'm starting with just offense. That's a good question. And I think that is actually what I mentioned earlier. So Sam asked if there was a reason I split it by years or instead of like just randomizing the data. I'm pretty sure that's why that one version of it got up to like 80% because I was feeding it the data at random. And so it started learning if it was seeing, week 4 of 2015, like it's seen it before, so it knows, what the results for it are going to be. And I think that's where that situation came out of. So Kevin asked if what different scenarios I've tried testing against. So like dropping week 1, dropping, whatever. I think once I cleared the data, cleaned the data and got rid of those data points that were really hit or miss. I just fed it every game And then, you know, each game that I would ask it to predict, it would get the previous 20 games for each team going into the thing. Trying to remember if I think I tried like getting rid of some data points and seeing what the results were. Especially like I figured ties wasn't going to be important at all. So I tried it with that and I don't think it affected things too much. How long did it take to run? I trained it a long time ago. It was like an hour or 2 or 3. Yeah.
Hey.
I'll get you. Sorry. Oh, there's one on here. Okay. Did you find a certain number of layers helped in either algorithm LSTM versus the first one? I did play around. So I didn't discuss the different layers, but like when you are putting together an algorithm, the way a neural network works is it has a bunch of different layers and it just like feeds random data into layer 1, which then feeds random data into layer 2, so on and so forth. And I'm trying to break this down live. And so if I'm doing a terrible job describing this, I apologize. But you can change those, make it a much deeper network if you want, make it a much shallower network if you want. I did play around with that. I don't think see very much difference when messing around with the different layers or how many layers, the depth of the layers, the number of neurons in each layer. I did mess around a lot with all that, and I don't think I saw too much difference. Yeah. That's a good question. So the question was, Biff had to guess on every game from 2010 to 2019. Did the human experts have to guess on every single thing? And I don't think they had to. I don't know how this data gets onto NFL Pick Watch. I could find nowhere else that gave me a history of people's picks about like NFL picking data. I don't know why, but there were, if I go back to the slide real quick, you can see there were like several, wrong one. So yeah, one of them's like 2020 to 2022, 2018 to 2022 is the biggest run. And then this guy down here is 2020 to 2021. So like, and I don't know which games they guessed on in those years. I don't think they had to do every week. Those were straight picks, not against the spread. Yeah. That's a good question. I haven't even thought of that. So the question was, I trained it on, 1979 to 2009, and then tested it on 2010 to 2019. Have I tried mixing that up, testing it on a bigger chunk of the data set, smaller chunk to see how that changed accuracies? I have not done that. And I probably will now. Right. The question is it 63.3% accurate against games being played today? And like not necessarily. It actually had a really, was it last year? Last year or the year before, it had a really rough year. Currently for this year, it's like 60 point something so far. We're only in week 4. And that 63.3% accuracy is for the stretch from 2010 to 2019, all those games. And so like, it's not necessarily going to perform that well or that poorly on a given season, but yeah, that's over that stretch of time. Okay, so the question was, how confident would I be predicting games that aren't necessarily this next week, but like weeks past that? I would be 0% confident because the way that you have to feed it, you have to feed it the data the same way every time. And so if I tried to feed it data that's unlike anything it's ever seen before, because like, let's say we're coming into week 5, right? And if I wanted to predict week 6, all of a sudden week 5 would be a bunch of zeros, and I don't think it wouldn't have any idea what to do with that. I don't think. Yeah. Yeah. That's a good question. The question is, how much would data from outside of Pro Football Reference, like if I pulled some of that data into the equation, how much would that affect the estimates? I'm not sure. I have thought about pulling in the spread because, again, the people at Vegas are good enough that a machine learning algorithm with hours of training time wasn't able to break 50%, then they probably know what they're talking about, right? So I have considered pulling some of that data in and putting it into the training data as well. So far, I've been pushing for like, I want no external like human knowledge added to it. Probably just I was inspired by the AlphaGo thing when it beat Lee. I don't know if it was the one that beat Lee or the one that came after. It had no human knowledge at all, which fascinated me. And again, just like for this thing to be 63% accurate overall, it doesn't know who Peyton Manning is. It doesn't know who Tom Brady is, right? It doesn't know that the Colts are like a powerhouse, you know, for this set of years or whatever. Like that, for it to know, like that just blows my mind. Let me check Zoom. Okay. All right. Well, if there aren't any other questions, thank you so much for joining. And thank you for your awesome questions. I'm definitely going to take some of those suggestions into consideration. We'll see. And again, if you want to see what Biff is doing on a week-to-week basis, follow me on LinkedIn, follow me on Twitter. I post it every Tuesday, Wednesday. Thank you.